Hello guys, welcome in the group guys. Yes guys, I'm fighting here to find a way I'm going to deal with you guys, cause yeah, I need to have a good camera and I'm busy fighting about that, but actually I'm going to make things a bit easy also. Yeah, let's start. So now I won't waste a lot of time because you can see on WhatsApp doesn't allow long videos. So guys, today we're going to talk about learning unit 1, electric circuit, and then concept Kirchhoff's circuit law or Kirchhoff's law, and one of the concept of Kirchhoff's law, which is junction rule. So guys, today we're going to talk about junction rule. Maybe some of you guys, some electrical students, so you guys know what is Kirchhoff's law, what is junction rule, and those all things. But some in the group are from other departments, so I need to explain this part because this is one of the concepts that will help us to master or to kill this unit. So guys, Kirchhoff's junction rule is the question of junction rule is about what is saying, like sum of current entering the node inside the node is equal to sum of current out of the node. So this is junction rule. So our node here this is the node. You can have circuit that has more, like say 2 or 3 or 4 or 5 node. Like in our case, I have only one node, and I choose that the current must flow from positive to negative. So like you can see the first loop, but we come back with another concept about loop. But for now, I'm busy dealing with junction rule. Like you can see in our first loop here, we have a current that is flowing from the source, which is from the voltage E1 that is flowing straight, that will going to enter inside the node, which is I1. And we have another loop this side, where we have also E1, so I2 from E2, and then we're going to have I3 that's going to leave the node. So like in this case now, how to apply this equation, the junction rule. So to apply the junction rule, this is our node. So that's sum of current that's entering the node. We have I1, and then we have also I2 that is entering the node, which is going to be plus I2, and then we have I3, which is equal to I3. We can say I3 is leaving the node, which is I3. So by the way, this is a junction rule. So my side in this circuit, I choose the node. I work with this node. I can even work with the node that is down here, but this time I need to choose now the current must flow from negative to positive. So this is the junction rule. But the way also, like I was saying, you can have type of circuit where you have like more than 2 voltage and more than one node. Like in this case, we have node 1, which is this one, and then we have node 2. So we can have we can generate 2 equations here. Like for the first node, regarding the first node, we're going to have I1, which is getting inside the node, and I2. So we're going to have I1 plus I2 plus I2, which is equal to I3 because it's leaving the node. But we have another node here. We can have another equation. We can generate another equation where we can say I2, we can see I3 is entering the node, but I6 and I5 is leaving the node. So we can say I3 it's equal to I6 plus I5. So like here also, instead of using node 1 and node 2, I can use instead of using these 2 nodes, I can use the opposite this side down here also. It doesn't matter. It depends because myself I choose to work from positive to negative, so that's why. So guys, in general, this, like in the simple way, this is the junction rule, one of the concept of Kirchhoff's law. This is one of the simple, but you must understand this concept to help us, for you guys to be good, or for you to kill this unit. Yeah, especially we're going to deal with this type of circuit where we have 2 voltage, you can see this. So you need to understand the concept of node and the concept of loop. So regarding, I can't make long videos for you guys for YouTube, for WhatsApp, so I'm going to stop here. I'm coming back again with another concept, which is another concept of Kirchhoff's rule, which is loop rule. And yeah, okay, I will stop here, and guys, okay, sharp.